Alright, today I am going to take a closer look at this little power supply that showed up in the last mailbag. It claims to be able to do multiple output voltages from power delivery type things or other methods of smart charger adjusting power, and it claims to be able to do 120 watts maximum when you're pulling power out of both the USB-A and the USB-C. I don't believe a word of it. So let's do a couple of quick tests and then do what we're planning on doing in the first place and tear this sucker apart. So first we'll just test the USB-A and see what it has to say for itself. Oh, come on, which way up are you? There we go. So that is 5 volts, near enough as you would expect. And the USB-C, if it's a smart charger, it should say nothing. But it says the same 5 volts. Here's what a smart charger should do when you plug into the USB-C with no load. Absolutely nothing. But then if you plug a load into it, say this USB soldering iron, it immediately jumps up to 20 volts as you would expect. And I haven't told the soldering iron to start heating yet, so that's why there's no current there. But, well, let's just do that. There we go. Up to 2 amps, that's cool. But that's in a real smart charger. In this one, yeah, it's only pushing 5 volts, and don't know whether you can see it on there. The soldering iron is complaining about 2 voltage, as you'd expect for a 5 volt power. So let's just check with the little Finersi USB power meter here, because it can detect the different power management protocols. So 5 volts is in green. But everything else is in red. This thing does not speak any known power delivery or quick charge format. As I sort of expected when I ordered the thing, but it was cheap enough that you never know, it might be real. The other thing, its prongs are smaller than standard, so it won't get a good grip in my power bar. So almost everything on the side of there is a lie. I'm not even going to bother and see if it'll live up to the 120 watts because I'm fairly confident that it won't. So now I'm going to assume that there is a seam between the black and yellow section that I can jam a spudger into, I hope. Oh, that is tight. Okay. That's opened up a little bit there. Let's get another spudger into the other side, and hopefully we can get into this thing. There we go. I see glue remnants along the side. Okay, so that just pops right off there, and that just drops out there. So what do we have on this side? We have our 4 connectors, we have the 2 mains connectors, 2 electrolytic capacitors, and a wee transformer. I don't know whether that 2A means 2 amps or it's just revision 2A of the board. Anyway, on the back side, we have a couple of little, well, that's not an 8-pin chip, that's a 7-pin chip in an 8-pin form factor. Bridge rectifier, little squiggly track pretending to be a fuse. We have a little bit of sticky stuff there, and aha! I'm going to assume that that trace is the ground trace. And this trace that's connecting to all 4 outputs is the positive trace. It could be the other way around, I'm not sure. Looks like there's a little resistor in between the 2 of them. That's unexpected. This thing over here is probably going to be some sort of power MOSFET. It's got 4 pins tied together there and 3 tied together there. And that is coming off the secondary of the transformer. There's one side of the secondary, there's the other side. That might actually be a diode. Anyway, it's got 1 standalone pin there, which doesn't appear to have a trace going to it. Oh no, it disappears underneath there. That is even more simplistic than I thought. Let's get some part numbers off the 3 main components, which is all that we're really going to be able to figure out from this thing. And yeah, simple enough. Maybe I'll draw a quick schematic of it too. I was getting up close and personal with these chips here. That is obviously a bridge rectifier. We don't even have to bother looking that up. This guy calls himself GP8892SEH. which is very likely to be a switching power supply controller type of chip. So after doing a bunch of searching and running it through Google Translate, that main chip is in fact a 10-watt flyback AC to DC main control chip. Now there's the block diagram of what's going on inside the chip. Unfortunately, Google Translate didn't translate that very well. But regardless, there it is in situ. So we have a bridge rectifier, which we do have, a capacitor, which we do have. The negative side is going into the ground of pin 7, which makes sense. The positive side is going through the primary of a transformer into pins 6 and 5, which, if we look at the internals, is the open collector of this drive transistor here, which makes sense. And then the feedback connects to pin 1 through a resistor and through this feedback coil on the transformer, which I'm going to guess we have. I haven't looked that closely yet. And then on the secondary side of the transformer, we have a diode, a capacitor, a load resistor for the capacitor, presumably, so that it bleeds down, and V out. Super duper simple. It doesn't get more basic for a switching power supply. Well, that took a little bit longer than I expected, but I think I've got a reasonable schematic, and it does look almost exactly like the sample that we saw on the datasheet for the main chip in here. I couldn't find a datasheet that matched the part number of this little diode here, but it can't be anything else, I don't think. At least the circuit wouldn't make sense if it was anything else. So we're just going to call it a big honkin' diode. And here's what that schematic looks like. We have the AC coming in over here. It's going through a circuit trace that is pretending to be a fuse. Out the negative side, just the negative side of the circuit, which is basically just the ground input of our chip. And of course, the negative side of our 47 microfarad 400 volt capacitor. 47 microfarad? No, 4.7 microfarad. Let's make that dot a little bit more clear. So that's across the bridge rectifier as you'd expect. The positive side of the bridge rectifier goes through the primary of the transformer and then across to the, that isn't feedback. Man, this is horrible. That is the C connection, the open collector of that little drive transistor, which is on pins 5 and 6. It also goes through this diode, this resistor with a little ceramic capacitor across it, through a 2.2 meg resistor and into VCC. But that 2.2 meg is also coming off here. Draw a dot just so that it's obvious. So that is what's powering the chip. That's taken care of. And then we have the feedback winding of the transformer. And it's usually shown on the primary side. It physically could be either, and it's kind of intertwined with everything, but regardless, it makes more sense to show it here. The feedback resistor, which is shown on the website, on the data sheet, in this case is an 11.3K going between the feedback pin and ground. And the only other thing connected on the primary side is this little ceramic capacitor here, which is, I believe, usually used for noise reduction, but again, it's just a little ceramic capacitor, and in these surface mount packages, there's no labeling, so who knows what it is. Right, secondary side, we have that 8-pin diode. We have a capacitor across it, which is not marked in any way. The only marking on it is that little Sharpie mark that I made because I had to pull it out to measure it. It measures at 921 microfarads. I don't know exactly what it is, but that's what my little tester showed me. It also has a 510 ohm resistor across it, and then a little ceramic capacitor across that, all in parallel, and then that just goes out to all of the USBs in parallel. And that's everything that is in there. Oh, yeah, that happened a couple of times while I was messing around. So, yeah, this thing is a complete lying bastard. One of the things it isn't probably lying about is it can probably take between 100 and 240 volts with your 60 hertz in, and it can put out 5 volts, but I'm pretty confident that it's not going to be able to do 3.4 amps at 5 volts. And I'm especially convinced of that because the chip can only do up to 2 amps or 10 watts, not the 140 watts that this thing claims. So the only value that there is in me buying this thing is to act as a warning to anybody watching to not buy it. Because it is, as I said a couple of times, a complete lying bastard. I'm not even going to bother putting it back together. Although, I guess if I wanted a low rent 5 volt, probably less than 2 amp power supply, I suppose I could use it for that. But I got lots of those lying around here. Anyway, thanks for watching. I do appreciate it. Questions and comments down below. Don't buy this thing. I'll put a link down below so that you can take a look at where I got it from and avoid any listings that look like that. Again, thanks for watching. I will talk to you later.